well, we left off kinetics, and now we're transferring from kinetics into this idea of equilibrium. Kinetics relates to the speed at which reactions take place, and equilibrium looks at reactions that look like they're not taking place. And I'll explain a little bit more about that. But equilibrium is where we're really going to be living for the next couple weeks. So almost everything we think about from this point forward can be thought about in terms of equilibrium and relating equilibrium ideas. And central to the equilibrium is this idea of the equilibrium constant, a constant associated with a given reaction at a given temperature, and the related equilibrium constant expression that numerically relates concentration and the equilibrium constant. And where this comes in handy is when we're calculating equilibrium constants, something that's actually quite simple to do, but more useful and more relevant is using the equilibrium constant to predict concentrations at equilibrium, figuring out what the concentration would be, and starting to play games where we change one concentration and see how that affects the reaction, which is tied to things like solubility, the solubility of a material in various pHs or various pH solutions or in water. And equilibrium is central to acid-base solutions and acid-base equilibrium. So that's where we're going to go over the next week.